The eye pattern display is available as an option for the LV5770. The eye pattern is a very important feature from the standpoint it allows you to be able to take a closer look at the condition of the digital signal. Outside of those ones and zeros making it from point A to point B and being able to display a picture on the other end, sometimes the condition of the digital signal may change as it goes through long lengths of cable or through various devices. And the eye pattern is really the key to being able to look and see what the condition of that signal is. So let's take a look at the eye pattern and let me point out some of the information that's provided with the eye pattern option. This is what the eye pattern display looks like. You've got a sine wave type display that you would have that you were looking at, let's say a very expensive oscilloscope would produce the same type of display. And it was called the eye pattern display many years ago. And below that we have information that's also obtained from that digital signal. Information such as the amplitude of the signal that you'll see over here. Right now we're indicating it's 762.5 millivolts. I know as part of the standard that normally it should be at about 800 millivolts, but within the standard you're allowed a tolerance of plus or minus 10% if I recall. So we can see that we're within that tolerance. Now the amplitude on that could drop down considerably and you could still end up getting a picture. But what that means is that when the amplitude gets too low, when it goes through another device, that device may have a problem with it. So this is a way for you to be able to tell just how bad or good the signal happens to be at a certain point. Besides that information, we also have other useful information for engineers, such as the rise and fall time, displayed in picoseconds over here in the left-hand side. We also indicate the jitter component of it. Jitter is also a very, very important part of that digital signal coming in. Sometimes long cable lengths or other devices may add jitter to the signal, may add errors to the signal, which could be an issue. So here we look at timing jitter, and we report that in picoseconds, and we also report it in the unit interval, which is the UI, as part of the standard. And we also have a report in terms of current jitter, and displaying it the same way in picoseconds and also in unit interval. And then over here on the far right, we happen to have overshoot information for rise and fall as a percentage. And right now, we're actually looking at alignment jitter as displayed right now. Okay? So, if we hit the eye pattern button and we go into the menu, you have some additional choices in regards to increasing the intensity of the eye pattern display or choosing a different color scheme for it, make it a little easier maybe to see. We'll go back to yellow, adjusting the intensity of the scale, and also changing the color of the scale. Going back up menu, you go to the eye pattern mode. This shifts you to a display that just focuses just on the jitter component of it. Okay? We'll go back to the regular eye pattern mode and we'll switch over to eye pattern setup. This is where you can make choices in regards to what frequency you want to look at in terms of where the jitter component is located. Anywhere from 100K down to simply just 10 cycles. Or you can set it for timing or specifically alignment jitter. Going back up menu, we can go to the error setup. This is the screen that you would use to go in and effectively enable all the warnings for, as you see there, amplitude, rise time, fall time, delta, timing, current jitter, overshoot information, and so forth. Turning those all on and enabling them will mean that if the signal goes out of the normal SMPTE specifications, then that information will turn red so that you'll know that the signal is out of the normal standard and out of SMPTE specification. An easy way to be able to see what's going on. And that's our eye pattern display. Again, a very useful tool to see what the condition is of the digital signal. Again, you can have a digital signal travel long lengths and still display a picture on the other end. But sometimes that signal can end up being attenuated, sometimes jitter, errors and so forth can be added to that signal. The eye pattern is a very useful tool to see what the condition of the digital signal is.